Hi guys, in this tutorial we're going to look at mesh analysis. Then I'm going to work out a bunch of examples to see how we apply mesh analysis. This is going to be a two-parts tutorial. In the first part we're just going to look at basic questions which you can work out using mesh analysis. So we're going to work out a question using this diagram, and then I'm also going to look at another using this. These are very basic examples which you can also work out using other concepts like Kirchhoff's current law and Kirchhoff's voltage law. But here we just want to see how we can employ mesh analysis. It's very easy and can easily be employed, especially in a case where you have multiple sources. Then in the second part, in the next tutorial, we're going to look at how to employ the same mesh analysis to handle questions where you have a current source, especially a current source that is positioned right on the middle. If a current source is positioned at the edge, the approach is a little bit different and it's much easier. But trouble comes when a current source is positioned right on the middle. So we're going to see how we handle such problems as well. That will be in the next tutorial. I'll leave a link to that tutorial in the comment section once it is uploaded. Okay, then this is going to be the big one, the last one. It's going to take us a little bit of time. Look at this, it has a lot of things to be done, but I'm going to see how it is supposed to be worked out as well. So let's see what we're supposed to do. What is mesh analysis? And let's start with what a mesh is. Well, a mesh is basically just a loop, but a loop that doesn't have any other loop inside. So we know to say in a circuit you can have something like this, where maybe you have this is a power source somewhere here. So this can be considered to be a loop. But if your loop doesn't contain any other loop inside, then it will be considered a mesh as well. Say you have something else that goes this side, and then you have something else that continues this side. In this case, you notice that you can have two independent loops. By independent, of course, I'm just talking about two loops which are in this case I'm just talking about two loops which are side by side, as in one is not inside the other. So here we now have two loops. Now this can be seen as one mesh, and this can be seen as another mesh. Now notice that you can easily claim that you can make a loop by just starting from here, going in this way all the way to the other side. You can argue to say that this is also another loop. But notice that the loop in blue now contains two loops inside it. This loop this side and this loop the other side. Because of that, the loop in blue does not qualify to be a mesh because it has more loops inside. For a loop to qualify as a mesh, it should not have any other loops inside. Another circuit that I can give you as an example is, so when you look at this circuit here, what you notice is that you can create a number of loops here, but the only ones that will qualify to also be considered as a mesh is going to be this loop here that doesn't have any other loop inside. This can also qualify as a mesh, doesn't have anything inside. And then you can also have this as a mesh and also this as a mesh. Now notice that what I'm saying here is that a mesh is basically a loop. So our approach to handling this mesh is going to be similar to, at some point actually we're going to employ Kirchhoff's voltage law, which was used to analyze a loop. For that reason, when dealing with a mesh, we keep on creating these loops. The direction that you choose is completely up to you, but in most cases we're going to be using the clockwise orientation. But once I pick clockwise, I'll stick to clockwise in all the meshes that I'm going to identify. So this is a loop one that comes out as mesh 1. This is another loop that is going to end up being our mesh 2. Then this will be our mesh 3 and our mesh 4. Now of course, the only difference between the original Kirchhoff's voltage law and when we use it for to analyze meshes is that now we will assign what we call the mesh currents. So the mesh current is just going to be a current that is going to be associated with each mesh. So this is going to be mesh current 1, then mesh current 2 here, then you have mesh current 3 here, and then you have mesh current 4. Now the idea here is that instead of having multiple currents in your circuit, to say you have got a current passing through the R6, then another current passing through R5 and so on, those can be many variables. Now mesh analysis reduces those multiple variables to just look at them as just I1, I2, I3, and 4. Of course, these currents can be related, in most cases will be related, especially where they are shared like this. But generally, it reduces from having multiple currents or multiple variables to just a few variables which are considered to be easier to work out. You'll see this to be most beneficial when you have circuits that have a display like this one. And also there's one question that I saw from a past exam paper where you could create up to 9 loops. So you had to literally create you had to do the mesh analysis for all the 9. Now such a circuit, of course, is going to be much more complex to work out using the normal methods, but mesh analysis gives us a way of actually analyzing the circuit with fewer unknowns. Then we can easily use the unknowns to relate them to the individual currents later on. So I will demonstrate exactly how you do that, but for starters, let's see how we use mesh analysis. And our first example is going to be something very easy so that you can easily verify our answers using other methods that we have used so far. Okay, let's look at this example. In this example, they're asking us to find the labeled currents and voltages in the circuit. Now, which ones are the labeled currents and voltages? So if you look closer, you find that we have I1 labeled here, I3 here, and I2 here. Then you have a voltage source here, a resistor, a 2 ohm. These are given, but then we have voltage V1 and voltage V3 and also voltage V2. So these are the 6 variables that they want us to find, and in this case we want to use the mesh analysis. So again, you can easily work out a circuit like this one using Kirchhoff's current law and Kirchhoff's voltage law. They will work, but here I'm leaving you to do the Kirchhoff's voltage and current law to verify the answer with the one we're going to find using the mesh analysis. Now, mesh analysis is derived from Kirchhoff's voltage law, so there really shouldn't be much difficulty in relating the two. Now, if I wanted to find the currents I1, 2, 3, even if they were not given, the first thing that I will be doing here is I want you guys to actually try to get used to that approach, because it will make your life very easy, especially when it comes to something that is as complex as this. So the first thing that we'll do, here of course the currents are labeled already for us, even their polarity or orientation is also indicated. So the first thing that we'll do is to relate those currents to the mesh currents. So here I have I1, 2, and 3. So let me just put those down, I1, I2, and I3. Now the first question is, how do these currents relate to the mesh currents? Because in mesh analysis, what we'll be working with will be the mesh currents, not the individual currents themselves. So first, where will our mesh currents be? So I'm going to say this is one loop. It doesn't have anything inside. So I'll take this to be to contain my mesh current I1. Then this side, or maybe if I don't want to confuse the labels of the individual currents to my mesh current, I can say this is my mesh current IA. Then the other side, I can put this loop to have my mesh current I2, IB I mean. Now, how does the individual current I1 relate to my mesh currents? So all I have to do is come to where that current is passing I1, and I see mesh current, that current, not the mesh current, just the current I1, it's passing in this branch. So which mesh current affects that branch? And clearly you can tell that the mesh current that affects this branch is basically just this mesh current IA. So because of that, and if you look at it, at the topmost part, mesh current IA is going in this direction, which is the same direction as our current I1. Because of that, we can conclude that I1 relates to our mesh current IA, and apart from that, they are in the same direction, so this is going to be positive. So in other words, I1 is equals to IA. The other thing that we want to see here is that IB does not interfere with I1. They don't interact at any point. So we won't relate I1 to IB. It will only be IA. How about I2. So when we come this side to look at where I2 is right on the middle. So if we look at it, I2 passes through this branch, and this branch is affected by both mesh currents IA and IB. Now if we look at IA is going downwards when passing through this branch, which is the same direction as our current I2. Because of that, IA and IB, first they will be related. I'll say I2 is equals to IA, but since they're in the same direction, my IA will be positive here. The next thing is, I indicated earlier on, or I mentioned earlier on, that IB will also influence what is happening in this branch. But for IB, notice that when passing through this 8 ohm resistor, IB will be going upwards, which is in the opposite direction to my I2. In other words, I2 will be affected by IB as well, but this time it is in the opposite direction. So I have IA minus IB. So that sorts out I1 and I2. The last one is I3, and my I3 is this side. So it's passing in that branch. So when I look at my I3, it's passing in this branch. Which mesh current affects that branch? And we see to say that it's only IB which affects that branch. Because of that, I will conclude that my I3 is only related to IB, but is it positive or negative? When passing across the 3 ohm resistor, for example, IB is going in this direction, which is the same direction as my current I3. Because of that, IB will be equal to I3, to be positive there. Once I've created the relationship between the individual currents to the mesh current, you see to say that if I was to find the mesh currents, I can easily get what the individual currents is. My approach to working out this question is to build on your knowledge of Kirchhoff's voltage law and help you use that to also find what the mesh currents are. Because mostly questions like these might ask you to say, what are the mesh currents? You know how to use Kirchhoff's voltage law, but how do you find the mesh currents? Okay, now after doing this in-between step that I like throwing in, the next part now will be to apply Kirchhoff's voltage law, which I feel, or which I would want to believe that you guys understand how to do very well at this stage. Now, let's see how it goes. Well, since we've created the relationship, even if we're not going to have these, they have saved their purpose, but of course we remember their orientation should we need them. Now, Kirchhoff's voltage law, how does it go? Well, we have to loop around the circuit, or around the loop. We have to create some form of a loop. Now, let's take this to be our first loop, so let's deal with it first. In Kirchhoff's voltage law, we sort of say there are 2 methods that we can use, so let's use the most basic one. When looping, all we'll be looking at is going to be where are we finding that source. We know to say Kirchhoff's voltage law states that the sum of all voltages around a closed loop is supposed to be equals to 0. So let's try to employ this technique. When we find the 10 volt power source here, we see that we enter it at its negative part. So this is going to be minus 10. So that's minus 10 volts. If we continued, we find a resistor, and this resistor is at positive 10. So again, I hope you guys have seen this in my other videos on Kirchhoff's voltage law. But if the polarity here was not assigned, it's up to you to choose the orientation. But of course, if you find your answer to be negative, it means that it's just the opposite of what your selection was. In this case, they have already been assigned to us, so we're just going to follow what is given here. We find the 2 ohms at its positive most point, so it's going to be plus. But to find the potential at the 2 ohms, it's going to be, they've used the labels as V1, so you can say plus V1. But we just have to remember that V1 is equals to the current passing there, which is I1, times the resistance there, which is R1. Of course, this is just 2 ohms times I1. I have no idea what I1 is, so take it like that. When we continue in our loop from the 2 ohm resistor, the next one we find is the 8 ohm resistor. Again, we find it at its most positive part. And notice that it's the last one that we're going to find till we come back to where we started from. So it will be plus, and that is labeled as V2. So it's going to be plus V2. And this is going to be equals to 0. In a similar way, V2 will be equals to the resistance, which is 8 ohms, times the current there, which is I2. That was I2. Yes, it was I2 passing in that 8 ohm resistor. With this done, I can substitute. I now have 10 plus where there's V1, I'll put 2I1, plus where there's V2, I'll put 8I2 is equals to 0. But I don't want to deal with the individual currents. For this example, you can actually deal with the individual currents and find them easily. But I want you to I want to relate this to the idea of mesh currents so that it will be easy for you to employ it when you deal with more complex setups. So I now use the relationships between the individual currents to the mesh currents that I developed earlier on, or that we came up with earlier on. I1 is the same as IA. I2 is IA minus IB. So this becomes, I'll take the minus 10 the other side, it becomes 2IA plus 8. Then I have I2 here, which is IA minus IB. This is equals to positive 10. Then from here, this becomes 2IA plus 8IB, minus 8IB. This is equals to 10. Simplify this, we now have 10 IA minus 8 IB is equals to 10. This can reduce a little bit, divide by 2, we have 5 IA minus 4 IB is equals to 5. This goes as our equation 1. Once this is done, we now go on to look at the second part, the second mesh. So we do the same thing. I can start from here. I find this at positive. So it's going to be the resistance times the current. Here the current passing is I3. So I'm just going to have plus 4 I3. That's I3. What comes next when I continue in this loop? The next is the power source. I find it at the minus point. So that's minus 6 volts. And then I continue, and next I find this resistor. I find it at its negative most point first, so that's minus what? The current times the resistance, so that's 8 times I2. So that's 8 times I2. This has to be equals to 0, that was the last one. Again, I bring back the relations. What is I3? I3 is the same as positive IB. So I have 4IB minus 6 minus 8. I2 again is IA minus IB is equals to 0. We simplify this. We now have 4IB. I'll take the 6 the other side. So I have minus 8 IA, then plus 8 IB is equals to 6. Reduce this a little bit. The 4 and the 8 will add. We now have 12 IB minus 8 IA is equals to 6. Divide everything by 2. We have 6 IB minus 4 IA is equals to 3. This becomes our second equation. Now, once we have these equations, we can easily work them out simultaneously. How you decide to work them out is up to you. When you have too many unknowns, sometimes it might be beneficial for you to use Cramer's rule. But here, of course, when they are simple, just be using substitution. So I can pick the equation 1, make IA subject. I will have IA here equals to 5 minus plus 4 IB over 5. If I make IA the subject of the formula. Then once I have made IA subject from equation 1, I can substitute into equation 2. So I now have 6 IB minus 4, and then 5 plus 4 IB over 5. Then this has to be equals to 3. Now I just have to solve this for IB. I'll multiply everything through by 5. This is going to be 30 IB minus the 5, and this 5 in the denominator will cancel. So I'll just have 4. Then 5 plus 4 IB is equals to, then this times 5 as well, that's 15. Reduce this again, 30 IB minus 20 minus 16. This is equals to 15. So group the like terms. Of course, we have that's 30 IB minus 16 IB is equals to 15 plus 20. Reduce. This is going to be 14 IB is equals to, and this is going to give us 35. So that we find our IB as 2.5 amps. So this becomes our mesh current IB. Using this, we can easily get this, plug it into this equation we came up with, and find what our IA is going to be. So if we bring this here, our IA becomes 5 plus 4, then we have 2.5 divided by 5. And our answer becomes 15 amps. So this becomes our mesh current IA. So if we wanted to find the individual currents and of course the voltages, we can then go back to these relations that we came up with. So the relations, sometimes questions will ask you to say just find the mesh currents, meaning this would have been good enough. These would have been our answers. But since in this case wanted to find the individual currents I1, 2, and 3, we can then bring them here. So we now know what the mesh currents are. IA is 15. IA is 15 amps, so I1 has to be 15 amps. Then we have I2 is IA minus IB, so this is going to be IA, which is 15, minus IB, and our IB was 2.5. So this becomes 12.5 amps. In the same way, IB becomes just equals to, as in, yeah, I3 is equals to IB, and our IB was 2.5. So these become our answers. So we have found what the currents are. The second part of the question was to find the indicated voltages, to find also V1, 2, and 3. So we know how we get voltage by Ohm's law. V1 will be equals to I1, that's I1, times R1. In this case, for V1, R1 is 2 ohms. So it will be the value we found for I1 times 2 ohms. That will be the voltage there. And V2 will be equal to the value that we found for I2 times the resistance there, which is 8 ohms. And finally, V3 will be equals to I3 times the resistance there, which is 4 ohms. So you can do this very quickly, and you're going to find the expected answers there. So this is how you go about this problem. Okay, so if you have something that looks a little bit like, let's say, this one here, so this one here, it's the same approach, but the only difference here is that now you don't have a voltage source here, you just have another resistor there. So you're literally going to use the same method to determine what these are. So you will come up with an expression for I1 in terms of the mesh currents, IA. And in terms of, again, this side, you're going to come up with another mesh current, IB. And then you're going to see exactly how they relate, how IA relates to the mesh currents, I3 relates to the mesh currents, and also how I2 relates to them. And then after you're done with that, you're going to come up, use Kirchhoff's voltage law for this loop and also for the other loop, then solve the two equations that will result. We can actually do this very quickly. This should just take us a few minutes, so I'll be a little bit fast with it. So here, I1 will literally be equals to IA, same direction, IB, I2 I mean, just like before, it will be equal to IA minus IB, and finally I3 will be equals to IB, same direction, just like before. And then when it will come to the voltages, we use the same concepts. V1 will be equals to I1. This will be multiplying 8 ohms. And then V2 will be equal to I2. This will be multiplying 3 ohms. And finally, V3 will be equals to, this is I2, will be equals to I3 multiplying 6 ohms. So all I would do is get the currents I1, 2, 3 for you, and then you easily work out the voltages. So with the relationships done, next part is to use KVL for each mesh. So we're going to pick the first one. So let's do KVL here. I find the 30 at the negative part, so I have minus 30. Then I find the 8 ohm at the positive part, so I have 8 I1. So this is going to be 8 plus 8 I1. Then next I find the 3 ohm positive part, so that's 3 I2 plus 3 I2. That's the last one, so this has to be equals to 0. Simplify this, the 30 goes the other side. Substitute the I1 and 2 by the respective mesh currents. IA minus IB. Then this is equals to the 30. Simplify this. Plus 3IA minus 3IB is equals to 0. Then this becomes, that's going to be 11IA minus 3IB, not 0. That's a 30 the other side. That's a 30. So this is equals to 30. So this becomes equation 1. Hope we haven't made any errors here. Then we go on to the second part. The second part, we're seeing only two things. We can start with the 6. We approach it at the positive part, so it's plus 6 I3. That's plus 6 I3. Then next we approach the 3 ohm at the negative part first, so that's minus 3 I2. So you have minus 3 I2. That was the last one, equals to 0. So you have 6 I3. Let's substitute. I3 is IB minus 3 IA. I2 I mean is IA minus IB. This is equals to 0. So you have 6 IB minus 3 IA plus 3 IB is equals to 0. Like and like, we have 9 IB minus 3 IA is equals to 0, so that IB will be equals to IA over 3. When I move the 3 IA the other side and divide by 9. So this becomes equation 2. We can then substitute equation 2 into equation 1. And if we did that, notice that now what we're going to have is 11 IA minus 3, where there's IB, we'll put IA over 3 is equals to 30. So that this is 11 IA minus the 3 will cancel, so that's minus IA is equals to 30. And then you have 10 IA is equals to 30, and IA will be equals to 3 amps. That's mesh current A. Then having found that, we can get IB. IB was equals to IA over, that was over 3, was it? Let's check it out. Over 3, yes. So if we do the same thing, our IA is 3. So this becomes 3 over 3, which is just equal to 1 amp. So our IB is 1 amp. Having found IA and IB, we can easily now get what the individual currents are. So just copy this, bring it here. Now we see that our I1 is the same as IA, which is just 3 amps. Our I2 is IA minus IB. IA is 3, IB is 1, this is 2 amps. Then our IB is 1 amp, so this is 1 amp. So these are our answers. Having found the currents, you can easily multiply them, take them back to the expression, and determine what the voltages are going to be. All right, so this is mesh analysis in its basic terms. Notice that if you have something that is like this, something that is more like this one, the only thing is you have to see that these will share here, these will share here. So I1 and I2 will influence the current in this branch. I2 and I4 will influence the current in this branch. And then I3 and I4 will control the current in this branch. So of course, look out for the next tutorial where I will be showing continuation of this, and I'm going to talk about what a super mesh is and how to actually handle it. A little bit tricky, but I'll try to make it as simple as I can. Now guys, let's interact in the comment section. Let's see what you guys how you guys found this question. See you guys in the next tutorial.